All right, hello y'all. Sorry I couldn't be there today, but we're going to do our lesson through this video. I'm going to go through the notes with you guys. Those are on the green paper. And then I'm going to go through a couple of the problems that are on the yellow paper. Now, the yellow paper is going to be due on Wednesday. Okay, so I'm going to be here on Tuesday, and so if we need to go over a couple of the questions, we can go over them on Tuesday, but the yellow is going to be due on Wednesday. Now, one other thing, please hold off on turning anything in until I see you tomorrow. So tomorrow, you should have for me your drawing that we did on Friday, and also the pink crossword puzzle that we did on Thursday, the day before. So I need both the drawing and the pink crossword puzzle by tomorrow, which you should have those done already, but I'll take them on Tuesday. So hold off on turning anything in. All right, so today we're going to learn about how to prove lines parallel. And so we're going to prove them by using the converse of our original theorem. Okay, so remember our converse, you just take P and Q and you switch them. So the converses of the postulate and theorems that we've learned about lines cut by a transversal are true statements. And then we're going to use different cases of it to prove lines parallel. So we're using the diagram over here for steps A through D, and we're going to complete the statements based on our work. So lines L and M are parallel, and because of that, we know that angle 4 is congruent to angle 6. And why are they congruent? Because they are alternate interior angles. Okay, we also know then that angle 6 and angle 3 are supplementary. And why are they supplementary? Because they're same side interior angles. And then additionally, we know that angle 3 is congruent to angle 7. So let me get a different color here. So we know that 3 is congruent to angle 7 because they are corresponding angles. All right, so step A. By the same side interior angles postulate, we know that if lines L and M are parallel, then angle 6 and angle 3, I guess we could zoom in, angle 3 are supplementary. Okay, because why? They're same side interior angles. Okay, so now step B, we're going to write the converse of the same side interior angles using the diagram and our statement in step A. So the converse. So we've got to take our conclusion, which was this, and write it first, and then our hypothesis and write it second. So if angle 6 and angle 3 are supplementary, then we can say that lines L and M are parallel. So basically, in these kinds of problems, they're going to tell you you've got lines L and M and they're being cut by a transversal. And they're going to ask you, are lines L and M parallel? And the whole purpose of this is that we can see if angle 6 and angle 3 are supplementary, then we can definitely say that L and M are parallel. We're just doing the reverse of what we've been doing. They've been telling us that L and M are parallel, and since they're parallel, we've been able to say that 3 and 6 are supplementary. So now we're just working the other way around. All right, now, alternate interior angles theorem. So we'll start off. If lines L and M are parallel, then Angle 4 is congruent to angle 6 because of the alternate interior angles theorem, because 4 and 6 are alternate interior angles. Okay, so now the converse. Start with our conclusion first. If angle 4 is congruent to angle 6, then we can say lines L and M are parallel. So we're just switching it. Okay, by the corresponding angles theorem. So corresponding angles, that's our 3 and 7. So if lines L and M are parallel, then angle 3 is congruent to angle 7 because they're corresponding angles. Okay, now the converse. If angle 3 is congruent to angle 7, then lines L and M are parallel. Okay, so that's all you got to do is if you know that 3 and 7 are congruent, then you could say the lines are parallel. If you know that 4 and 6 are congruent, then you can say the lines are parallel. If you know that 6 and 3 are supplementary, you can say the lines are parallel. Okay? And so now they've just got them written out formally right here for us, so you can see all those. And so now we will do an example. So it says a mosaic designer is using quadrilateral shaped colored tiles to make an ornamental design. Each tile is congruent to the one shown here. The designer uses the colored tiles to create the pattern shown here. Use the values of the marked angles to show that the two lines L1 and L2 are parallel. Okay, so we can go on ahead and we can label. If you can see here, I'll kind of outline. There's our angle. There's our separation between the tiles. So we have L1 and L2, and then they're being cut by this line. That's the line between the two tiles. So that's our transversal, remember? The line that is cutting the two parallel lines, that is called a transversal. So let's go up here to our diagram, and let's kind of label our angles. We know the top one is going to be 120 degrees, and we know the bottom one is going to be 60 degrees. Now think about this. What's the relationship between here? They're on the same side of the transversal, and they're both on the inside. So let's fill in. The measure of angle 1 is 120 degrees. The measure of angle 2 is 60. And so the relationship between them is that they are the same side interior angles. Okay, and since they are supplementary, because 120 plus 60 is 180, we can say that L1 and L2 are parallel. So let's go on to the back. So conclusion. L1 and L2 are parallel. Okay, so now look at this situation. Use the values of the marked angles to show that the two lines are parallel. So let's go on ahead and let's label. If you look back on the front, we know that this one here is 120, and this one here is also 120. So the measure of angle 1 is 120. Measure of angle 2 is 120. And I'm referencing our original picture on the front. Okay, this one that tells us the angle measures. All right, what's the relationship between angle 1 and angle 2? Well, guess what, guys? They're in the same spot. So they are corresponding. Corresponding angles. And so our conclusion, if corresponding angles are congruent, then we can say that the lines are parallel. So L1 and L2 are parallel. All right, so now we're going to go through here and we're going to do a couple problems. So example 2, use the given angle relationships to decide whether the lines are parallel and explain your reasoning. So angle 3 is congruent to angle 5. So identify the relationship. They're on different sides of the transversal. They're both between the parallel lines, so it's alternate interior angles, right? Okay, are the lines parallel? Yes. And why are they parallel? Because if the alternate interior angles are congruent, then they are parallel. So since angle 3 is congruent to angle 5, L and M are parallel. Remember those two lines, that's our symbol for parallel. Okay, so let's go over here. The measure of angle 3 plus the measure of angle 6 equals 180. So what's the relationship between 3 and 6? They're on the same side, they're both interior, so they are same side interior angles. And so are the lines parallel? Yes. Angle 3 and angle 6 are supplementary. So L and M are parallel. Okay, next one. The measure of angle 4 is x plus 20. So x plus 20. The measure of angle 8 is 2x plus 5. And x is equal to 15. So identify the relationship. So 4 and 8. Do y'all see how they're both in the same spot? That means they are corresponding angles. Corresponding angles. And so now we need to determine if the lines are parallel. And how are we going to do that? We only know that these two have expressions for their size. So what we got to do is plug in the x value that they gave us and actually figure out how big these angles are. So x plus 20, right? So that's 15 plus 20. That's 35. That's angle 4. And then angle 8 is 2x plus 5. So that's 2 times 15 plus 5, which is also 35. Is angle 4 congruent to angle 8? Yes. So they are parallel. So yes, angle 4 is congruent to angle 8. L and M are parallel. Okay, that's really all there is to it, guys. We're going to come back to this constructing parallel lines later. So we're done with the notes portion right now. So everybody do me a favor. We're going to go over to our assignment, the yellow paper. So we're going to start off with a couple of these problems. So it says write the theorem that proves the lines are parallel in problems 1 through 6 below. So essentially I want you guys to tell me why these two are parallel just based on the angle relationships that they give us. Okay, so let's go on ahead and see here. 62 degrees and 62 degrees here. So let's think about this. What have we been using? We've been using alternate interior angles, we've been using same side interior angles, and we've been using corresponding angles. But we can also use this relationship. What's the relationship between these two angles called? Alternate exterior angles. So alternate exterior angles are congruent. Exterior angles are congruent. Lines are parallel. Okay? All right, let's do Here, I'll help you out a little bit with number 4. I'll give you a hint. You see these two right here, the 41 and the 41? Does it matter that those are congruent? No. 41 and 41, those are vertical angles. So all the time when you have two lines that are intersecting, the vertical angles are going to be congruent. So you cannot use vertical angles to say that lines are parallel. So you're going to have to use this 41 degrees here and the 139 and try to remember the relationship between those. Okay, so that'll be pretty much it for all the rest of them. Number 3, don't let these right angles throw you off. Just look at the relationship between where the angles are. Okay, that should help you with that one. So let's try one down here. All right, number 7. It says find the measure of angle 3, assuming lines L and K are parallel. So they're telling us that the lines are parallel, so we can make certain assumptions about these angles. And what is the relationship between these angles? They're in the same spot, so we call that corresponding. So if we know that they're corresponding, do we know that they're equal to each other, meaning congruent, or do they add up to 180? They are congruent. So we can say 14x plus 9 is equal to 5x plus 90. And then now let's solve for x. So get rid of this 5x first, so minus 5x minus 5x. So we have 14x minus 5x is 9x plus 9 equals to 90 minus 9 minus 9. Okay, 9x equals 81. Divide by 9 on both sides. X is equal to 9. Now we need to find angle 3. This is what we need to know. Now what's the relationship between this 5x plus 90 and angle 3? They make that straight line, so they have to add up to 180. So now your task is to go in and plug in 5 times 9 plus 90 and find out what that is, and then do 180 minus whatever that number is, and that's going to tell you angle 3. Okay, so you guys finish out number 7, and number 8 is the exact same way, y'all. Look at the relationship between the 6x and the 3x, and then whatever that relationship is going to tell you how to find x, and then from that you'll use another relationship between angle 2 and the 6x so you can find the measure of angle 2. Don't just stop at x, you got to plug in. All right, an example on the back here. On all these ones, you're going to go through and you're going to use the reasoning that they've given you and then tell if the lines are parallel and why. So an example, number 1, angle 1 and angle 2 are supplementary. So which lines are parallel and why? Okay, this is going to be a little bit tricky with this diagram. You're going to have to learn when you need to look at certain lines and when you can ignore certain lines. Right now, do you see how angle 1 and angle 2, they're going along the same line, O, line O? That's the transversal. We need to look at the two that are crossing line O, which are L and M. So since 1 and 2 are supplementary, we can say that lines L and M are parallel because, so L and M are parallel because angle 1 and angle 2 are same side interior angles. Okay, so just kind of, you have to go through and decide which line is the transversal and which ones are parallel, and then give me the reason. You're telling me the relationship between the two angles, and that would be how your reasoning goes. And that's the rest of them down here. On number 6, you've got to look at your lines and look at your angles, and then decide who is going to be correct, and you have to explain your answer. So just make sure you're going through there, looking at all these, and this is going to be due on Wednesday. So if you have any questions on it, you need to bring them to me for Tuesday so we can go over them. All right, so you're going to use the rest of the class period to work on the yellow paper, maybe finish up the drawing, maybe finish up the crossword puzzle, but we need all that stuff done for tomorrow. And then the yellow paper, the one we're doing right now, is going to be due on Wednesday. So I'll see you guys tomorrow. Have a good rest of class. Bye.